Hello, today we're going to look at a little bit more work on probability. I've got 5 themes running today. One is a very simple probability exercise. The second one involves looking at coins and probability space. The third one is tree diagrams, and we're going to look at two different situations with tree diagrams. Relative frequency, this is where we look at probability experiments and compare that with mathematical or theoretical probability. And the final topic is Venn diagrams. Okay, let's look at the first activity. I'm going to sit down for this. So in the first activity, if you can see here in front of me, I've got a simulation of a fish tank with a number of fish in there. And sometimes in probability questions, very simple ones will just say, what's the probability of picking out any given colour of fish. So if we look at the rainbow fish, there's only one of those, and if we count all the others, there's 9 more. So the probability of this would just be 1 out of 9. Similarly, if they said, what's the probability of picking a yellow fish, we can see here there are 1, 2, 3, 4, 5 yellow fish, and there are 10 fish in total in the tank. So the probability would be 5 out of 10 or a half. And the final one they might ask you is what's the probability of picking a white fish, and if we count them 1, 2, 3, 4, you can see there are 4 out of 10, so the probability would be 4 out of 10 or 0.4 if we're using decimals. Now something I want to introduce here, if you can just have a look at this question poses how is 4 over 5 different from 4 to 5? So looking at the two terms here, this particular first one is a fraction, 4 out of 5 parts. This one here is a ratio of 4 to 5, the colon indicating that it's a ratio. Now they're not the same. 4 out of 5, imagine we've got 5 fish and 4 of them, that's an example of that. But in this case, if we add these two together, we have 9 parts. So this will be 4 out of 9 and this will be 5 out of 9. And that's one of the reasons why we never write probability as a ratio. We always write them as a fraction or as a decimal, and we can write them as percentages. In fact, the Americans like to write them as percentages. All those are acceptable, but not ratios. Okay, moving on to a different model. I'm going to move this one away. Here we have more fish, a lot more this time, and again, if we sometimes you get probability experiments where you remove a fish and don't replace it, or you remove an item and don't replace it. So if we look here, we've got 13 fish in the tank, and if I take one out, let's say we just take out one at random, which happens to be yellow, we now only have 12 fish in the tank. So if we count them, just counting the yellow ones, we've got 1, 2, 3, 4, 4 out of 12. And in probability, we can just write 4 out of 12, or we can simplify it. In a maths examination, you wouldn't lose any marks if you didn't simplify it, unless the question specifically asks you to do so. So 4 out of 12 could become 1/3. And similarly, if we count the white fish, we have 8 left, which would be 8 out of 12 or 2/3. You'll notice as well that 4 out of 12 and 8 out of 12, if we add them together, we get 1. Same with 1/3 and 2/3, if we add them together, we get 1. And in probability, all these examples are based on a probability of up to 1. So anything between 0 and 1. So the fractions or decimals can anything between those two scales. Okay, now we're going to go on to a second topic, and this time we're going to have a look at a probability space, which involves looking at coins. So we'll go to that next.